5, 4, 3, 2, 1, top.
Going on this trip is, in a way, going back in time.
Allumage Vulcain. Décollage.
We are sending these spacecrafts to comets to learn more about ourselves, our existing, our life on Earth, our solar system.
Instead of bringing a sample back from a comet nucleus, that we would bring a laboratory to the comet and study the comet with very great detail.
There are a lot of experiments. We wanted to know everything about the comet, magnetic field, composition, and temperature, everything.
Nobody so far has done such a complex mission to a comet.
We went around the Sun 5 times and we came very close to planets in order to use their gravitation to accelerate. This is the first spacecraft that actually flies beyond the orbit of Mars, if you want, beyond 200 million kilometers from Earth with solar panels. We did also something very exciting. We crossed twice the asteroids belt, the main belt between Mars and Jupiter, and we took the opportunity to fly by asteroids.
So isn't that fantastic? It's really spectacular. So it's a new world discovered by Rosetta.
This is just the beginning. I mean, if this is the way the thing begins, try and imagine how it's going to end.
This is really what the last 2.5 years were about. Silence. This will end in January, on the 20th of January.
We made it.
There you are.
Yes. We can definitely see the signal from Rosetta. It's up there. You can see it on the screen. That's a big success for everybody. Now we got it back. Now it's up to us to drive it to the comet.
Around 7th of May this year, we started our science operations. At that time, we were about 1.5 million kilometres away from the comet. At that time, only OSIRIS, our scientific eye, could see the comet and started to infer what we're starting to see now, that something special was happening.
We first measured water in the comet in early June, and we have been tracking it ever since. We're seeing the gas from the comet rushing toward us.
What we see from the ground, say from observatories on Earth, is the large-scale behavior, the big picture, the coma, the tail. But what really drives the comet, the real heart of the comet, is the nucleus.
So we're go through the maneuver. We don't have contact with the spacecraft right now. We have to wait 22 minutes to get the results on ground, of course. We're at the comet!
Yeah!
So from imagery, I can confirm we arrived, and it's the best comet nucleus ever resolved in space.
10 years to build the spacecraft, 10 years to get there, and now I think we will have more than 10 years to exploit all the science these people will dig out of this comet.
In the short term, we have a task to do. We want to characterize the nucleus, the comet, the activity, to try and set up and start the process of deciding where to land in November.
We are flying at 55,000 kilometers an hour, 30 kilometers next to a comet. This is an absolute unique achievement.
This is not an easy task. And you see there is flat areas, but there is also rough terrain. There is some cliffs, there is some boulders. So we just have to wait for 7 hours now until we land.
We're going to sample the comet for real.
What we are trying to do here is extremely difficult, extremely challenging.
It is the core of exploration, because we are going to places we have never been, and all what we can model is nothing compared to reality. Reality is much more fascinating.